Today we'll learn about bubble sort, basically time complexity of bubble sort. So we all know that bubble sort works on this loop I equals to 0 and I less than n. Then there is another loop for j equals to 0 which goes like from less than n minus 1 minus I. And there is some piece of code written here. There is some piece of code written. So we are mainly concerned about these two loops because we need to find the time complexity. So how this thing works is for I equals to 0, our j is running n minus 1 minus 0 equals to n minus 1 time. For I equals to 1, our j will run n minus 2 time. Similarly, it keep on going, and there's a time when this loop will run only once and 0. So for I, there's a time when it will run for 0 and 1. Now, what uh, we need to do is, like, there are total number this similarly n minus 3, n minus 4, blah 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 blah. So the total time it takes for running is n minus, not this, just a second. So total time it run is 1, 2, 3. Similarly, this keep on going 1 plus 2 plus 3 plus 4 plus this keep on going, and this goes till n minus 1 times. So you can see this is the uh, sum of n numbers and sum of n positive numbers, which the formula is n minus 1 by 2. Like sum of first n natural numbers, first n natural numbers. So opening this n by 2, n by 2. Now in time complexity, we take the worst case for consideration. Like worst case, for example, n is very large. Like we'll not decide it for n is basically iteration, so we'll not decide it for 5 or 10 iteration. We'll decide it for 10 to the power 8 or 10 to the power 7, some these iterations. So let's say n is equals to 10 to the power 8 here. So 10 to the power 8 whole square minus 2, 10 to the power 8 minus 2. So this thing makes up to 10 to the power 16 by 2, and this thing still remain 10 to the power 8. Now in front of 10 to the power 16, 10 to the power 8 is very small. Wrong. 10 to the power 16 is very much large in compared to this 10 to the power 8 thing. So what we can do, we can ignore this 10 to the power 8 thing. We can ignore this because it's quite small in front of 10 to the power 16. So we are left with 10 to the power 16 by 2. Now we are left with n minus 2, basically n minus 2. This n minus 2, this half can be written as constant. This can be written as constant k. So kn. And in time complexity, we ignore constant because it won't do anything. Dividing like 10 raised to the power 16 dividing by half, it won't do anything. Still, the computation power of our computer is quite large. So constant hardly do anything. Mainly powers like raised to the power 2, raised to the power 3. These things bring the change, not half or multiply by 2 and something like that. So what we have now, uh, just a second, let me erase this. So now we have this n square by half. This was n square, not half, because we took the square there. So k n square, k n square, and as you know, like you, we declare the time complexity thing is big O notation, like big O, and then we insert the time complexity. For example, there can be n log n time complexity O n square complexity. So this thing is big O. So in this, we'll just put this big O and we'll put this n thing. So n square. So this is the time complexity of bubble sort. And that's how you calculate time complexity for other things also, like for Fibonacci series, Fibonacci series, and you can compute for factorial, for merge sort we can do. Like for everything, how many times the loop is running, and in the worst scenario, like here we took the worst scenario of this thing. Worst scenario was 10 to the power 8 thing. If we'll take for 5 iteration, 10 iteration, obviously this will pass and computer will hardly take milliseconds to compute this. But this thing, these things are large, so it takes quite a few time.